Okay, lesson 2. So today's focus of the lesson is about zero exponents and negative exponents. In yesterday's lesson, I sort of hinted towards a zero exponent, and I already gave you the solution. But let's talk more about it today. And also, with negative exponents, we will be looking at that for the first time. So let's start with the first example here. All right, we have the original expression 2 squared divided by 2 squared. Or another way of saying 2 squared is 2 to the power of 2 divided by 2 to the power of 2. So we learned in yesterday's lesson that we can take this and we can say, well, this is 2 to the 2, and then you subtract this exponent because there's a division here. So it's 2 to the 2, take away 2. Well, 2 to the 2, take away 2, well, actually gives you 2 to the 0. But let's see what happens. What does this evaluate to? Well, let's write out what we have in expanded form, okay? So 2 to the power of 2 divided by 2 to the power of 2. Well, it's the same thing as me saying 2 times 2 divided by 2 times 2, right? Okay, well, there's a few ways to approach this. You can cross off everything you have here, but if you were to just actually evaluate it, what's 2 times 2? Well, up top you have 4, and on the bottom you also have 4. Well, what do you get when you evaluate that? 4 divided by 4. You get a value of 1, right? Okay, that's why another way of showing this, when you take 2 times 2 and you divide it by 2 times 2 and you cross off everything, when you were essentially simplifying, it's not like this equals 0. No, it all goes to a value of 1. It equals 1. That's because you can see right here, right? You have the same thing on the top, and you're dividing by the same thing on the bottom, and you get a value of 1. So in essence, when you have 2 to the 0, let's just, before we create a rule, when you have 2 to the 0, you get 1, all right? Well, let's do it again here. 3 to the 4 divided by 3 to the 4 ends up meaning we subtract our exponents, so you get 3 to the 0. Well, just like we did in the previous example, we have 3 4s up top, and we have 3 4s. No, sorry, we have 4 3s. I was like, I think I said that wrong. So if you cross off each one of these, right, because they cancel. Actually, let me just go into a little more detail about that. Let me rewrite it again. Sorry about that. So we have 4 3s. I said it right this time. So you're canceling off. So it's like this one divided by this one. 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 So you're essentially saying, well, doing this same thing top and bottom again, you get a value of 1, right? Well, 3 to the 0 also gives you 1. And same thing would happen here. 7 times 7, 7 times 7 times 7. Well, we have the same thing top and bottom, so all of these cross off, and we get 1. And this is like me saying 7 to the 3, take away 3, you get 7 to the 0, right? Mathematically, using our quotient rule, well, we can just show that 7 to 0 also 1s. So look how it didn't matter what the base was. I made it 2, 3, 0. Regardless whatever the base is, anything put to the power of 0 is 1, okay? So the general rule is that any base value, we give it the value b, put to the power of 0 equals 1, all right? And in writing that in words, any number put to the exponent, put to the exponent, 0 equals 1. All right, well, let's explore negative exponents now. All right, so again, two focus of today's lesson. Well, using our quotient rule again, we have the base 2, so we have 2 to the 2 divided by 2 to the 3, so you take away 3. Well, 2 take away 3 ends up being 2 to the negative 1. Well, this is something we haven't seen before. How do you deal with a negative exponent? All right? What it does not mean, okay? Again, second most common mistake, all right? 2 to the negative 1 does not mean negative 2 to the 1, okay? This is the number one most common mistake, okay? Please do not do this. Do not do this. All right. So let's figure out what it actually means. If we were to expand this out, right, write it in fraction form, well, you have 2 to the 2 up top, so that means you have 2 times 2. And then you have 3 2's on the bottom. 2, 2, and 2. All right, well, let's use our simplification. So this 2 cancels with this 2. This 2 cancels with this 2. Okay, well, when we cancel our 2's up top, it's not like we get 0 up there. Remember, this all actually simplifies to a value of 1 up top. And then on the bottom, you still have this sole 2 left over. So you actually get 1 over 2. Okay, well, notice that we have the final answer being the same base. You see you have this number here, 2. That's right here. The only thing is you get it what's called a reciprocal, okay? Where you take the base value and you go 1 over the base, right? You get 1/2. So in exponent form, 2 to the negative 1, well, we just showed you actually get 1/2. All right? Same thing. Let's show it again here. So using our rules of quotient, we get 3 to the 4, take away 6. So then you end up with 3 to the minus 2. But let's see what your final answer is when you go 3 to the minus 2. Well, we have 4 3's up top. And on the bottom, you have 6. So 1, 2, 3, 4, 5, 6. Start simplifying. So this 3 and this 3, this 3, this 3, this 1, and this 1, and this 1. All right, so what are we left off with? Well, we have 1 up top because it doesn't go to 0. And then we have 3 times 3 on the bottom. Or another way of saying this is you have 2 3's. So you have 1 over 3 squared. Right. We started with, we showed that, well, technically 3 divided by 3 to the 4 divided by 3 to 6 is the same thing as me saying 3 to the negative 2. And that ultimately ends up giving you this. So 3 to the minus 2 gives you 1 over 3 squared. We're starting to see a pattern here, right? And let me actually put a 1 here too to make it more clear, the pattern. Notice what the negative is causing for your exponent, okay? Let's show it one more time. So we have 7 to the 3, take away 6. So another way of saying that is 7 times 7 times 7 up top. And then we have 6 on the bottom. So 3, 4, 5, 6. Start simplifying. So 1 cancels, this cancels, this cancels, this cancels. And notice then you're left with 1, and you have 3 7's on the bottom. So I can write that as 7 to the 3. Okay. Oh, I should have simplified this, sorry. 7 to the 3 take away 6 is minus 3. All right. So then 7 to the minus 3 we just showed is the same thing as this. So 7 to the minus 3 is 1 over 7 to the 3. So notice that the negative exponent is causing you to take whatever your base is and just writing it as 1 over that. But then you keep the same number, okay? So if I have a general rule, right, using kind of the same concept we wrote above, if I have some number, base, put to the exponent of negative n, well, that is the same thing as me saying 1 over the base put to the negative n. And you might also see it commonly like this, okay? You might also see it as in a bracket, and we will see this, to the negative n. This means you just take whatever's in that bracket and you write it over, 1 over, and then you just keep it as a positive exponent, okay? So the negative exponent, negative exponents, all right, create or cause the base to be reciprocated. Okay? And that just means 1 over the base. All right, that's just a fancy way of saying that. It just means flipped over on its side, okay? So, again, we just proved all this, all right? So the 0 exponent, all right? I mean, this is just saying that you can't have a base being 0, right? That's just fundamental in math. You can't have 0 to the 0. You can't have anything. You can't have 0 put to the power, you can't have 0 to the 0. Like, this is a fundamental math, like, that breaks down. But I won't really test you on that too much. But main thing, know that x to the 0, or anything to the 0, is 1, all right? So the negative exponent law, x to the 1 over n, to evaluate a power with a negative exponent, rewrite the power with a positive exponent by taking the reciprocal, which we just wrote, okay? Of the original expression. So notice here, negative exponent, all it causes you to do is rewrite the same thing, just 1 over, but now with a positive exponent. So let's go through a few examples here, all right? And most important thing, especially in this first example here, is your use of brackets, okay? So this is actually a good example to start with right off the bat. You might think this is value is equal to 1, right? Because we said anything to the power of 0 is 1, which is true. So anything put to, my dog was just barking there, so I made a cut in the video. But as I was saying, so you might think that anything to the power of 0 is 1, which actually is the case, always. But in this specific scenario right here, right, this is not a negative 1,000 put to the power of 0. What you're actually seeing here is you see negative 1 times 1,000 to the 0. So what this gives you is negative 1 times, well, yes, this put to the power of 0 gives you 1. So negative 1 times 1 gives you negative 1, all right? If this was negative 1,000 put to the 0, you would get positive 1, okay? So notice the use of brackets, right? You get a completely different answer. So always be on the lookout for that. All right. So B. Well, we have a negative exponent. So let's work with the inside first. So we have negative exponent. So you write 1 over and then 4 to the 3. All to the 0. Okay, well, technically I have this. This right here is my base. So if you think about it, this is like me saying my base to the 0. Yes, it's a fraction, but it's still just a number. Anything put to the power of 0 is going to give you a value of 1. All right, next one. Oh, sorry, missed one. C. Let's go through this. All right, so 5 to the negative 2 times 5 to the negative 4. Well, we have the same base being multiplied, all right? So why don't we add our exponents? This is technically like me saying 5 to the negative 2 plus, because we're adding, because they're multiplying, minus 4. So then you get 5 to the minus 2 minus 4, which is the same as me saying 5 to the minus 6. And then how do we deal with the negative exponent? We take the reciprocal. So 1 over 5 to the 6. And there's your final answer. Just to show you, we could have also done this a different way, okay? There's multiple ways to go about using your exponent laws. Notice how here I used the addition. I used the multiplication rule first, which is why I added my exponents. You could have also approached this by dealing with the negative exponent first. You could have said, oh, you know what? I see a negative exponent. I'm going to deal with that. So that 5 to the negative 2 would have been 1 over 5 squared. And then multiplying 1 over 5 to the 4th. Same thing over there. Well, you, again, have two fractions multiplying. So you multiply top, bottom. But you have what's on the bottom, that's what I meant by again, is you have same base. So you go 5, 2, plus 4. And in this case, you'll get 1 over 5 to the 6. So notice how they're the same answer. They're equal to each other. It doesn't matter what approach you take, okay? So that would be pretty common. Like you might be thinking, if you're watching this, like, oh, I would have done this way. That is probably valid as well, right? There's multiple approaches to the same problem. So let's look at D, okay? So my way, and the way I see it is, you know what? I'm going to use the power to a power rule first to deal with that, instead of me reciprocating this. So I'm going to approach this problem like this. I'm going to say 3 to the negative 1 multiplying, well, 2 to the power of negative 4. Remember, power to a power, you're actually going to multiply those exponents. So that's 2 multiplying negative 4 from our previous lesson. So that's 3 negative 1. Nothing changes there. But now you get 3 negative 8. Well, now you have same base. So, and they're multiplying. Add your exponents. 3 negative 1 plus negative 8. Well, that's going to give you 3 minus 9. Now deal with the negative exponent. So you take the reciprocal of your base. So this is 1 over 3 to the 9. Okay. So your base here is a fraction. So when you have a fraction, right, the negative value applies to everything inside the base. So you take your fraction and you reciprocate it. So you just reverse it. So if you're reading it as 3 over 5, it now becomes 5 over 3 to the positive exponent, okay? So your fraction inverses. This negative here causes these to flip. So now we get our 5 over 3 to the exponent, and just so we did in the previous lesson, remember this is like 5 to the 1 and 3 to the 1, so that is a power to a power, so that 2 multiplies that 1 and that 1 down there. So you end up with 5 squared, or 5 to the 2, over 3 to the 2. F. So here we have multiple powers to a power. So careful. This is all 3 of these being put to the power of minus 3. So that means like this 2 technically is 2 to the 1. This A is technically A to the 1. And then B is B to the power 2. So all of these, okay, get hit with this exponent. So this negative 3 multiplies that 2 to the 1. So let's carry down this bracket. So you technically have 2 now being put to the negative 3. This 3 multiplies that 1 right there. So you have this A being put to the minus 3 as well. And then you have that 3 multiplying that 2. So that is now B to the minus 6. And then close your bracket. So this bracket right here. All right, so keep track of your brackets. That's honestly one of the hardest things about this unit. And then you still have this negative 1 exponent here. So that's still up top here. So now do your power to a power once again. So this negative 1 multiplies this negative 3 here. Okay, well you get 2 to the, what is negative 3 times negative 1. All right, well, we'll evaluate that in a second. And that's being multiplied. Okay, again, all these things are being multiplied. A to the minus 3 being also multiplied by negative 1. So that negative 3 is being multiplied by negative 1. And then again, you have your base, sorry, not base, but b to the minus 6. And that is being multiplied by negative 1. So multiplying by negative 1. All right, well, 2 to the negative 3 times negative 1, well, that's just 3, positive 3 now, right? Anything times negative 1 will flip the sign. So then you get a to the 3 as well. And then you get b to the 6. And there you go. That's your final answer. All right, notice how if we use the other power to a power, we're actually able to simplify it and just ignore those negatives altogether. We didn't have to do any flipping of our fractions at all. Okay. So, G. Oh, did I miss one? F, G? Nope, into G. All right, well, we have a power on the far outside there. So we're going to take that 2, and we're going to put it to the power of this, this, and this. All right, so if we clean up that, and also, sorry, on the bottom, and that 4 right there. So let's do it in steps, okay? Let's do it in steps. So you have equals. Well, 2 to the 6 to the power of 2 becomes 6 to the power of 2. Then you have x, and that has a power of 0, so that 2 and that 0 multiply. So 2 times 0, well, you still get 0. Then 2 times that minus 3 right there, well, that's y to the minus 6. And then 2 to the 8 down here, well, that's 8 to the 2. And then 2 times that y to the 4, well, that's y to the 8 now. Okay. Well, let's simplify a bit. So here we have 6 squared over 8 squared. Well, those aren't similar bases, so we can't do anything. So we're just going to leave that as 6 squared over 8 squared. Well, x to the 0, that's just 1. Remember, anything to the power of 0 is 1, so that goes away. Right? Well, I mean, technically you'd have a 1 here, but we don't write that because anything times 1 is itself. And then we have y to the 6 being divided by 8. So really this simplifies to being multiplying minus 6, and then because they're dividing, it's taking away the exponent on the bottom. So you have 6 squared, 8 squared, multiplying y to the minus 14. Okay, but deal with this negative. Well, that's the same thing then as saying 6 squared over 8 squared times 1 over y to the 14. Okay? Well, you have two fractions multiplying. So 6 squared over 8 squared y 14. H. All right, well, we have a bunch of multiplications going on up top. So let's distribute like we would do in the previous units. So negative 6 multiplying negative 9, well, you're going to get 54. So positive 54, so 54. And then you have x times this x right here, because multiply similar. So those are same bases, so you add exponents. So that's x, you have a minus 2, and then you add the minus 5. And then you have the y, multiplying that y over there. So that's y to the, technically this is a 1 here, so 1 plus negative 2. Okay, so we dealt with everything up top, and on the bottom, nothing happens, so we just have this, minus 4. So let's clean up top. Up top we have 54. X to the negative 2 plus negative 5 gives you negative 7. Y to the minus 1. all over 3x y to the minus 4. Okay, so now we have to simplify our exponents. So we have similar bases here on the bottom of our fraction. Remember, those are being divided, and same with right here. So we have 54 over 3, right? Because technically your coefficients also divide. And then we have x minus 7, and it being divided by, technically that's a 1 here, so minus 1. And then y minus 1, take away negative 4, okay? So keep in mind your signs here. Negative right here, so you subtract a negative. So 54 divided by 3, I don't know why my mental math is not great right now, but I'm pretty sure that's, yep, it's 18. So that's 18, x to the minus 8, and then y cubed. Well, we never want negative exponents, so deal with this. So that's like me saying, technically, 18, and then times 1 over x to the 8. X to the 8. Times y cubed. Well, that's like 18 over 1 and y over 1, so you multiply all your denominators by each other and all your numerators by each other. So you get 18 y cubed over x 8. Okay, example 2. Well, we have negative 3 to the quarters to 0 plus 2 to the negative 2 times 3 squared. Follow BEDMAS here, okay? So deal with brackets, exponents, division, multiplication, addition, and subtraction. So, technically, this is me saying negative 1 times, well, 3 to the 0, 3 quarters to the 0, that simplifies to 1. 1 plus 2 to the negative 2. Well, this simplifies to plus 1 over 2 to the 2. Then we have this being multiplied by 3 squared. So 3 squared is 9. Okay, well, we have negative 1, because we dealt with our exponents, right? Like that was BEDMAS, that was the e, we dealt with that. Now we go to the next steps, division and multiplication. So I have a multiplication going on right here. So that is me saying negative 1, and then plus, so plus is not priority, and then I have another multiplication right here. So that is me saying, well, 1 quarter, because that's what 1 over 2 squared is, multiplied by 9, and that's the same thing as me saying 9 over 4 plus 1. Well, now I deal with my addition, so I need a common denominator, so that's technically negative 1 over 1. So common denominator, multiply both by 4. So that's negative 4 over 4 plus 9 over 4. Well, that is 5/4. There we go. Let's do the same thing for b. Okay, well, we're going to use our power to our power rule. So 2 times that 4 right there. So that's 4 to the negative 4. Multiplying, well, we still have that 4 to the minus 3. Nothing changes there. And we can put that in a bracket. And then on the bottom, well, we have technically a 1 here, so let's distribute that in. So 2, so that's 4 to the negative 2. Well, notice we have same bases, right? So I want you to get used to seeing this. Well, up top, you can write that as 4 to the minus 4. And then, because you're multiplying here, you're going to add that negative 3, so adding negative 3. And then on the bottom, you are technically, this whole thing is a division, right? So then you are also subtracting that minus 2. So notice how I was able to put them all on one line, okay? Because they're all the same base. So then you get 4 to the minus 4 minus 3 plus 2. Clean that up. That's 4 to the minus 7 plus 2 is minus 5. So then 1 over 4 to the 5th, and then it asks us to actually evaluate, so we do need to evaluate this. So 4 times 4 times 4 times 4 is 1 over, times 4 again, 1,024. Last problem. So deal with the negative exponent first. Again, we're dealing with bed mass. So before we multiply these, all right, we need to deal with the exponent. Or actually, you know what? Actually, I'll do it that way because I did say that. So we'll do exponent. So we're going to flip this. So this would be the same thing as me saying 3 over 2 to the third, because now it's a positive exponent. All I did is I flip the base, multiplying by 2 over 3 squared. We'll now distribute the 3 to both the 2 and the 3 on that bracket. So we get 3 to the 3 over 2 to the 3. Actually, we don't need a bracket anymore. Times, we'll do the same thing here. 2 here and 2 here. So that's 2 to the 2 over 3 to the 2. Okay, well, let's write that all in one line. Let's do this multiplication now. That's 3 cubed. Oh, and technically 2 squared. Actually, you know what? That's going to confuse you. Let's not do that. So notice here you have similar bases. Okay, here and here. So technically these are all being divided. So we have 3 cubed being divided by this number right here. See, that's why you subtract 2 there. And then you have multiplying 2 to the 2, and you're dividing by this one. So that's minus 3. So you get 3 to the 1 times 2 to the minus 1, which is 3 times 1/2, or 3 over 2. See how that was one method to go? And how, I know I cut myself off in the beginning there. I was going to do it. I can show you another method. Doesn't matter, you got the same answer. At the very beginning, these are actually similar bases. You have 2/3 being to the negative 3, multiplying 2/3 to the 2. Similar bases being multiplied. Add exponents. 2 over 3 minus 3 plus 2. Well, that's 2 over 3 to the minus 1. Deal with the negative exponent, so it tells you to reciprocate your fraction here. So you get 3 over 2 to the minus 1, which is really just 3 over 2. Notice how you get the same answer, okay? So actually, the second method, way faster, much easier. But you might not always see it right out of the gate. But that's okay. Doing this method also, perfectly valid. You just have to be good with your fractions and good with your exponents. So there's no right answer. So in this unit, I'm marking more on the process, doesn't matter. I'm not marking on what process you take, but just your work as you go through it. Okay. So again, this takes a lot of practice to get used to it. So please do the homework in class, and I'll see you then. Bye for now.